Okay, so we need to expand this out. Just continuing on from the last video, got interrupted. So x squared minus 6x plus 9 in the brackets. And then distribute the negative. So that's going to be negative x squared plus 6x minus 9 plus 4. And underneath, negative x squared plus 6x minus 5. Okay. Equation and domain of g of x. So g of x is a line, but it's starting at a point. So we're just going to give the equation of a line, and then that starting point is going to be defined by the domain. So if you take a look here, down 2 to the right 1, it's a little off there. So that is slope of negative 2. And so if we were to extend this back up, we'd have a y-intercept of 4. So this will be g of x equals, it's a negative slope, so negative 2x plus 4. Okay. All right, so state the values of f minus g of 1. So looking at this, we want to, let me just erase these markings here. So when x is 1, what is f? It's 0. Okay, when x is 1, what's g? 2. So 0 minus 2 is negative 2. Then when x is 3, so f is 4, g is negative 2, so 4 minus negative 2 is 6. And then at x equals 6, our f, a little bit off, is negative 5, and our g is negative 8. So negative 5 minus negative 8 is positive 3. So our 3 points here will, oh gosh, okay. That's going to be 1, 2, oh sorry, 1, negative 2, 3, 6, and 6, 3. Plot these points on the grid and a few more. So 1, negative 2, sorry, I'm a little bit off, 3, 6, there we go, and 6, 3. Okay, so, and then a few more points. So, because we can't really tell, we know there's nothing's gonna be to the left there because our g of x is not defined for x less than 1. But let's get a couple more points. So we are subtracting. So remember that our f is the quadratic. So let's do at x equals 2, f is 3, and g is 0. So that's going to stay at 3. Then next one, when x is 4, that's 3 minus negative 4. That's going to be 7. And then at x is 5, that's going to be 0 minus negative 6 is 6. Okay, I apologize for my dots. I'm doing this sort of by hand. Okay, so now I'll try my best to do a parabola, and I'm a little bit off. That's better. And then it's going to be like this. Okay. So it's a little bit messy, but you can kind of tell that the vertex is 4, 7. So the equation is y equals a times x minus 4. Let me just fix that. Plus 7. And you don't even need to use algebra. For 1 unit over, it's 1 down. So that means our A value is -1, so we can just show it as a negative. So that's in vertex form. It doesn't say that we have to show it in simplified form. But what we could do is check, right? So if we are subtracting f minus g, so we would take a look back up at these and subtract them. So that's going to be negative x squared. 6x minus negative 2x is positive 8x. Negative 5 minus 4 is negative 9. Okay, let's see if we expand this out. We get negative x squared plus 8x minus 16 plus 7 is minus 9. And that's the same. Okay, so yes. And the domain, we have to look at our original domains, right? Oops, I guess I forgot to state the domain. So f of x here is all real numbers. G of x is x greater than or equal to 1. So where do they overlap? They overlap for these values. Okay, so that's going to be our domain of this one. So state the domain is going to have to be x greater than or equal to 1. Even though it extends further, we have a dot there. Okay, then the next one we're going to multiply. So at 1, the two values are 2 and 0, so that's going to equal 0. Anytime one of the y values is 0 and you're multiplying, that's going to stay as an x-intercept. F of 3 times g of 3, so that's going to be 4 times negative 2. Then at x equals 4, we've got 3 times negative 4. Still does, oh gosh, okay. Thought I'm doing this video on a touch screen, and I thought that it wouldn't do those errors. In any case, what did I just say that was? 4. That's going to be 3 times negative 4 is negative 12. Oh, and that just got rid of it. So just give me a sec. Okay, so then our 3 points are 1, 0, 3, negative 8, and 4, negative 12. Okay, so if we plot those, okay, we need a few more. So choose, say, when x is 2. Anytime any of these original graphs cross the x-axis, when you multiply, you're still going to have an x-intercept because one of the y values is 0. So that's going to stay there. And then let's do when x is 5. So that's going to stay. And then let's do when x is 6. So that would be negative 5 times negative 8 is 40, way up high. Let's think about what we're doing here is multiplying a quadratic by a linear. So that's degree 2 by degree 1. That's going to be a cubic. So we can estimate, and again, I've got to try my best here, is to estimate that kind of zigzag graph. Okay, so I'm a little bit off. I'm doing this with my finger. So bear with me. Try to fix it a little bit there. It's a little bit squiggly. Let's see, that's a bit better. Oops. There we go. This is approximately anyway. Okay. So write the equation in factored form. Oh, in factored form, yes. So we want to multiply this out. Okay, so we've got negative x squared plus 8x minus 9 multiplied by negative 2x plus 4 Okay, so multiply through. Okay, and collect like terms. Now, I think I forgot an x squared somewhere. Another x squared, so that minus 16x squared. So that's going to be minus 20x squared, 40 plus 50x minus 36. Okay, now saying that, take a look in factored form. I've expanded. Actually, I didn't even need to expand out because we can just factor each of these. So I'm going to factor out a negative. I'm going to factor out a negative 2. Okay, bring that, so I'm going to just bring it down here. Okay, so negative times negative 2 is actually going to be positive 2 out front. X squared minus 8x plus 9 factors to x minus 9 times x plus 1. And then times x minus 2. And then, of course, the domain, x has to be greater than or equal to 1. Okay. All right. Last thing is working with discrete functions. So this one here, we just have to look at the actual values. And so H has a whole bunch of ordered pairs, M has a whole bunch of ordered pairs, and we're going to evaluate. So if we're trying to find H plus M of 4, then we need H of 4, which would be negative 11, plus M of 4, which would be 3. Add those together is negative 8. Then M of 0 is 2. H of 0 is negative 3, and we're subtracting. So 2 minus negative 3 is 5. Then H of 2 is negative 5. M of 2 is 0. Negative 5 times 0 is 0. H of negative 4, take a look. You don't see it. So this, we don't even look at M. No. So this is undefined, does not exist. Actually, I'll just put does not exist. You can abbreviate that with D and E, does not exist. Then M of negative 2 is, let's do a different color here. Let's do purple. M of negative 2 is negative 6. H of negative 2 is 8, so negative 6 over 8, and that reduces to negative 3/4. What's the domain of H of x? So you just list them out, negative 2, negative 1, 0, 1, 2, 3, 4. And domain of M is negative 4, negative 2, 0, 2, 4. Therefore, if we're adding, subtracting, or multiplying, what's the domain? Well, we can only do that for common domain values. So -4 isn't, -2 is, -1 isn't, 0 is, 1 isn't, 2 is, 3 isn't, 4 is. In terms of h over m of x, so it would be that this, but we remember we can't have m being equal to 0. So you want to look at m. When do we get a y value of 0? We get that when x is 2. So we're going to have to eliminate that from our domain. So it's just going to be -2, 0, 4. Okay, and then switching around, start with -2, 0, 4, but now h can't have a value of 0. So when does that happen? Never. So that's going to have the same domain as adding, subtracting, and multiplying. Okay, so then write out the following function in its entirety. So for multiplying together, remember we can only do it for x values. So here we have to use it for our defined x's, -2, 0, 2, and 4. Okay, so then what do we get? So when we multiply them together, so let me just erase this. So, so -2, that's 8, times -6 is -48. Then when x is 0, we've got 2 and -3, so that's -6. Doesn't like it when I scroll. Then when x is 2, that's -5 and 0, so that's going to be 0. And then when x is 4, that's -11 and 3, so -33. Okay, so now you can continue with the practice.